And Dr. Walton's going to talk to you about something that you need to know for your report. And that thing is the process or the pipeline. Whoever's talking is not going to get those marks in their assignment. You need to know the pipeline for the production from, and we using multi-sim, right, or multi-board. How do you get from multi-board to the piece of plastic, fiberglass and copper that you hold in your hand that's ready to solder the components on there? So how do you do that? So Mike, if you take us through that, please.
Okay, so on the screen I have a wonderful PCB developed by
Star.
Woods himself. So
A
the
star.
first question for some extra points here. What do we think is potentially missing from that? If we wanted to move this board into production and actually get some sales out of it or get some use out of it, what are we missing on that board? Anyone? £10 for any good answer. Time's up. So, no ideas. No one's got any ideas. If we drop that board and we got that here, we could put some components on it and sell it and everybody would want to buy it, yeah? So,
I think maybe we used to have a yellow wire. I forgot what it was.
a yellow wire.
A yellow instead of red. After you finish something, it turns it into yellow.
I'm not sure I understand what you're saying on that one. It could be what you're talking about is the overlay or something, where you see the text and stuff. But there's something a little bit more fundamental. I mean, that is a PCB, and it will do the job that we wanted to do. It's got some resistance, a transistor, everything's great, but what can we do with it? Are we going to sell people a PCB? It's going to need some kind of enclosure, isn't it? That would be number one. And if it's got an enclosure, what do we need? How could we put that in an enclosure?
By enclosure you mean a box, don't you?
Or whatever it's going to go in.
Yeah.
What's it going to do? These are the things we need to think about. It's not just about putting the components in the board and getting manufactured. How are we going to fix it in the board? So we need some holes or something, don't we? Or some idea as the final product. Because having 1,000 boards turn up on your bench is not going to be a sales release, right? We need some kind of holes, and then we need to think, we've got some inputs and some outputs, haven't we? Yeah, some bits coming into how are we going to deal with that? In this case, there looks to be some holes, which means if I'm going to give that as an end product to somebody, how is that going to work? Are we going to expect them to solder wires in? Very doubt that. So are we going to pre-solder some wires to hang off? Or should these really be connectors? Are they knobs? If they're knobs, where are they fitting on the board? Especially on the edge. How can we get them out of the enclosure? If there's an LED on there, how can I use the CD LED? Where is that LED placed? All this kind of stuff is just as important as getting that board working. Yeah? And we need to make these decisions before it goes off to manufacture. Because if we put 4 holes in the corner there, then they're going to drill those 4 holes through. So when we end up with these boards back in the quantity, we can then assemble them and get them sold. Yeah? So it's not just about the board. You've got to think about the whole thing, and, dare I say, it would benefit your report if you show that you thought about every stage to the point where your PCB is not only manufacturable, but sellable. Because that's really what you're here for, isn't it? So that's the first thing that I'm going to say. The second thing is we need to understand the size of our board. It's really important. We need to understand how many layers we're using. In this case, we've only needed 1 layer. But every component is a through-hole component, which means it's going to be soldered on the other side. So we're either going to spin the board around and solder through the bottom, where the legs are on the top layer, where the copper is there, because as you can see, in the red, we're in the copper bottom and the copper top, red and the green. But we put everything on 1 layer, so that means if it's through hole, they'll have to go through the other side. So we need to keep that in mind if we're doing an enclosure for it as well, I mean, because those components will have some height factor, and they can't hit the box. So all of that you can get an idea by looking at your 3D preview. of how your board's going to look like when it's done, and you can get an idea here, how can we stick that in a box, etc., all that kind of thing, okay? So the second thing then is, how can we now pass all this information on to the fabrication flow? We've got a whole bunch of layers down here. So this is your design toolbox. This is where we can choose. If we want to put, if I want to put a trace on the other side, for example, yeah, then we can double click this copper top, and then you can actually draw traces on the top hand side by simply drawing the line. Yeah, and then you will see at the moment that's still on the wrong layer. If I was to go onto the copper top there, and draw that same line. See, now I've got a different colour that's going on, and that basically means that I've put that trace on the other side of the board. Yeah, so you can click between both sides of the board. Take that off. And then what we'd have to do is send all of these files to the Fab Lab, and they will then etch the copper top separately to the copper bottom, and then press them all together. Okay? So, the next thing to do is to export this information into a known format that the manufacturers can use. Yeah? So, to do that, how to do that in export. Okay, so we have this file export, and then up in the scheme, normally we have fabrication of metric, which is selected by default. Yeah? And what this is going to do is this is going to give us a Gerber file and an MC drill file. These are the two important documents that we need to export. The Gerber files are basically the CAD files of every single layer that you produced in your multi-board project. Yeah? And the MC drill file is the CNC file that controls the drill machines for exactly where to drill the hole and the size of the hole. If you miss either of those, then your project is going to come back as unmanufacturable, and they're going to ask you to supply the information. If you then want to get it populated as well, you're going to have to include the container files and the bomb and the materials. Have you done bombs then?
And done bill of materials.
And done bill of materials. So bill of materials, when you do an export, when you're ready to take it to manufacture, you export what we call a bomb, which is a list of every component you've included in your design, the part number of that component, the quantity of that component, price of it, where you're able to buy it, and you quite often have to compile this list for sale. So again, when you deliver your assignment, you are probably expected to deliver all the files that are needed to manufacture your board, as well as the documentation in terms of the report. A bill of material, so that you are able to find out or show what components are needed. And a bill of material is not just, we need 4 resistors of 1K. You need to actually be able to buy those components. So you can't have obsolete components. You can't have a component where you have a minimum order quantity of 10,000, which there are a lot of, so you need to be careful of that. If you've got 4 resistors, then obviously you want to build 10 boards, and you're going to need 40 resistors, potentially 50 in case you drop a few. So then you have to worry, okay, can I get 50 resistors in a reel? Can I get 50 resistors in the tube? Are they all separate? If they're all separate, then the fabrication part's going to charge you a lot more, because they're going to want it in a tape strip or tape reel. If you're placing it yourself, it doesn't matter. So you need to take all that into consideration as well. So when we come to export, I would strongly recommend that you leave all the defaults, okay? Because what's going to happen is it's going to export the copper top and copper bottom, the board outline, which is this yellow bit. If you want to change what your board looks like, if you want to make a circular board or you have some specific shape that you want to go, you can go to the board outline layer, and if you then change this yellow outline, then that's what the manufacturer plant will cut your board to. So typically, when it goes to manufacture, they will want to work in panels. Okay? You've got a board, and they will want to not just make one piece. They would hopefully want to make 100, and let's say they want to make 10. What they would do is panelise your board. So they'll get your design, and then they will repeat it 10 times, and they will create a panel, and they will either create break tabs between each one of your designs, so that when you get it, you can snap them on, or they will do V-scoring, which is where a cutting blade doesn't cut quite all the way through the board, and it gives you the ability to snap. Yeah? But that's how the fab plant will work. They never just make one board for you. There's going to be a big board, and if you are prototyping your board, you're going to have a huge, great big lump of FR4, massive, and you're going to have a space on that FR4, and it's going to be shared with other customers. So the fab plant is going to take your design with a whole bunch of other people's designs and fill that massive board up, etch that whole board, cut them all out, and send the right bits to the right people. So that's how they get those costs down. Okay, so we are then going to file exports. Yeah, we're going to check that we've got the other files selected and our individual files. And we're just going to leave all of this as default. We'll stay in metric. Typically, and I don't know why, schematics have always been drawn in metric and PCBs in imperial. So we use the word mil, but when we're talking PCB, it's MIL, not MM, and it's actually that. Thousands of units. But in this case, we'll just leave it as metric. Okay, it gives you the option here to export your bill of materials as well, but again, that's not needed for this particular export. So I'm going to hit export here. So it's telling me that I've got some warnings because I've just drawn this huge, great big trace on the outside, but that's okay, I'm okay with that. I'm going to ignore the errors. Now it's asking me that this already exists, I'm going to overwrite it. Okay. Right, and what that's going to do is if we look down here, it's going to tell us that we've exported everything into these files. And it's going to tell me where I've exported it to. And here they all are. So all of these files here are the files that I've just exported. Each one of these individual files represents a different layout on that board. Yeah? I need to make sure that I send them all.
And the TBR extension is just to pick up on there as well.
Yeah, and the rep for the drill information because you need to get those individual files as well. So I select them all and now I send that to a zip file and I'll call that my design. PCB design. Okay. So now I have this file, and I know that, because I put these dimensions on, and the dimensions have been put on the silver sheet at the top. Typically you would put dimensions on the mechanical layer, because that's for you, and if it's on the mechanical layer, it won't get manufactured. Right? So you'll be able to put all dimensions on. So I know that this board is 56.3 by 48.25. So I can now choose the prototyping fab, and the easiest one to go with is PCB way. Okay, and then on PCB way, you have the ability to do a prototype, yeah? And the first thing it's going to ask is our length and the width, and we know that we've got 56.3 and 48.25. So we go 56.3, 48.25. How many do we want? We're going to say 5. It's a 2-layer board and a 1.6mm thickness, yeah? And now, it's going to ask me for an account. I don't know if you have an account for this. Do you have an account?
John's got one, yeah.
John's got one.
Awesome, beautiful.
FR4, which is the material we're going to use. Okay, so we're going to choose FR4, which is the material we're going to use, yeah? If we need to choose a different material because we're doing a high-speed board or an RF board or something like that, in this case FR4, it's a fiberglass board. We've got two layers. TG130 means that the technology that we're going to be manufacturing to, and TG130 is the cheapest one. It's all about the temperature the board can be cooked into and the minimum size of your hole. So it's another thing that's worth noticing on this PCB. These tracks are nice and wide. If you just use a default value, you might be doing a 1,000 track, which is absolutely tiny and probably going to break during the etching process. So you need to know the capabilities of your manufacturing track. And normally their minimum can be 6 by 6, which would stand for a minimum of 6 thou width and 6 thou clearance between two tracks. Yeah? If you go smaller than that, and they're capable of doing it, your cost will go up. So my advice, keep the tracks as fat as you can, because it really does make things easier. But understand, if you are running a power line, then you're probably going to want to keep that track a lot wider than a signal line, because then your impedance is going to be less when higher amperage are going through. Yeah, so you need to understand that. Because of the tracks, when they make the PCB, it's all about copper, and there's a copper thickness that goes on the top of that PCB. And you can choose whether you want 1/2 ounce copper, 1 ounce copper, which sticks on top of this track to build it up. So if you have a width of that track and a height of that track, and the fact it's copper, then there is a maximum current that that track can convey, isn't there? Yeah? If you go past that, your track's going to burn out.